We're given this sum from n equals 1 to infinity, and we want to see if this converges or diverges. So I can think of this as n times n to the 1/2, which is n to the 3/2 power. So I can rewrite this sum as 3 over n to the 3/2, and this is going to converge because of the p-test, and p here is 3/2, which is greater than 1. Okay, the next problem, we have the sum from n equals 1 to infinity, 5n over 2n minus 1. If I look at this limit is going to be 5/2, which is not equal to 0. So this diverges by the nth term test. The next sum we have from n equals 1 to infinity, -1 to the n, 3 to the n minus 2 over 2 to the n. So we know that this looks like an alternating series because of the -1 to the n power. So for the alternating series, we have to see that the limit goes to 0, it's decreasing, and a sub n is positive. So a sub n being this part right here. Now, let's do a quick check to see if the limit goes to 0. Well, this is actually a geometric series. So if I were to ignore the -1 to the n, this is a geometric series, and I'm just going to write it like this. So that would just be 3 to the n over 2 to the n, and then 3 to the -2 goes on the bottom as 3 squared. So that's basically 1 over 9. And so I can factor out the exponent, and we know that the ratio here is 3/2, which is greater than 1. And obviously this is going to diverge. Right, so this limit is going to go to infinity, obviously, because the ratio is greater than 1. And so it will not satisfy the limit going to 0. So this diverges. Next sum we have from n equals 1 to infinity of cosine of n to 3n. So this has potential to look like a geometric series, and we would expect this to converge because 1/3 is the ratio. But obviously we don't have 1. So what we're going to do is find something bigger. So we know that 3 to the n is just 3 to the n, whatever. But we can find something bigger than cosine n, which is just 1, because we know 1 is an upper bound. And we know that this is going to converge. 1 to the over 3 to the n converges because the ratio is 1/3, which is less than 1. The absolute value is less than 1. Okay, so by the comparison test, anything smaller will converge. So this also converges. Okay, last example, we have the sum from n equals 1 to infinity, n times 7 to the n over n factorial. So this looks like a good problem to use the ratio test. So we're going to plug in n plus 1 in for n to find the n plus first term. And then we're going to divide this by the nth term. We know that we're going to multiply the top and the bottom, so that will just be n plus 1 times 7 to the n plus 1 times n factorial. And then we're going to divide that by multiplying these two. And we want to make sure we go in order. So n plus 1 will put n first, and then 7 to the n, and then finally we'll leave the factorial, so the n plus 1 factorial. So this is lined up nicely. We'll leave the n plus 1 over n alone. Now the 7 to the n plus 1 and 7 to the n, we'll be left with 7 and then n plus 1 after we cancel out the factorials. And the good thing is this n plus 1 and this n plus 1 will cancel. So all we're left with is 7 over n. And now we take the limit of this thing and see that it is 0. So this will converge because it's less than 1. And yeah, and this is by the ratio test.